Yeah.
You're on the
There you
air
go.
now.
Okay. So let me, oh, where am I going to put you guys? I usually have three monitors. Today I only have two because everything's breaking on me. Um, so I'm one slide a bit early. Oh, wow, I'm really early. It's like I've never done this before. Okay, now you can see my screen, title page.
Yes.
Okay, perfect. Done. Okay, so I started making this presentation last year because I kept hearing about how great Fabric is, data mesh, all these other frameworks. And I was really confused because people and vendors tended to use the terms in wildly different ways. So that was kind of weird. So I developed this as a shorter form thing, and now I've expanded it into a full session thing. That's me. And like you said, I'm Microsoft MVP and MCT. And also, what else am I? Oh, I'm a NASA Datanaut. And you're going to find out that space stuff is really important to me. Oh, and I was going to turn my camera off too. Do that. That way I can scowl at my screen and not have to worry about it. So interrupt me at any time to ask a question, make a discussion, leave kudos, leave complaints, or anything like that. I'm really informal when I present. So I have a little commercial here. I didn't clear this with anybody, but I hope that you'll like it because it's not a for-profit thing. So I said I'm a NASA data That means I'm a volunteer with NASA to help citizen scientists, citizen data scientists as well, work with space open data. And so one of the things that has happened with space open data is about 12 years ago, NASA decided to build a hackathon to encourage people to work with open data, and that's called the SpaceX Challenge. Um, the SpaceX Challenge is the world's largest global hackathon with participation from more than 140 countries with hundreds of thousands of people. So I'm a mentor and a judge in this. It's all volunteer. And right now, you can see the dates for the one coming up is October 4th to 5th. Now, what I love about this hackathon, because I haven't been a programmer since the Reagan years, and this is all the challenges are about data. So that's why I want more data groups to be involved in this. So I pulled up, there's usually a couple of dozen challenges, also a pick your own challenge. So look at data and try to do something with it. Every year they have a theme, and the theme, is usually about societal benefits or climate or something. So I think last year a lot of it was about climate, and you can see this is just three of the challenges, and they have challenges for coding. One year they had make an ontology. They have robotics one. They have art, so STEAM related things that you do art based on the data. I just want more data people I consider my tribe, to be involved in this. It's almost always programmers. And some of the challenges, like the one to build an ontology, they don't have anyone entering it because the people entering are developers or data scientists who want to do analytics, which is all a good thing. But, it can be a lot of fun. And so then, I like everything spacey. And this is Chicago from space. Just thought I'd throw that in. You can see Lake Michigan there. So I already talked about why this topic, but it is because I love data. So one of the things I always talk about when I'm talking about futures is what are our current challenges in data management strategy. So I think I've been saying data volume and complexity for the entire 35 plus years I've been doing this. But it's always growing and making things harder for us. Real-time access to data has been around for a while, but what I'm hearing is, when I talk to people, is they want real time, like from a sensor that has to travel across planet, get put into some data lake and be able to do analytics on it. People are wanting that real time. Definitely, there's always uptick in data privacy and compliance regulations. Sometimes they conflict with each other. Data security becoming more and more important. And then this advent of new data architectures and frameworks. And then, of course, it's 2025, so no presentation should skip mentioning AI and ML. So some of the things that contribute to this complexity is data quality. Data quality is what I love. It's what I think I'm here for. But I say it to the complexity because as we'll talk about these frameworks, there are impacts to how we manage data quality. And also data quality isn't always about data or, you know, accurate data, because there are some data feeds that we can tolerate a lot of missing data, miscalculated data. That, as someone who grew up in the transactional database world, that was really hard for me to get my head around, because that was our ultimate goal, is perfect data, consistent data. And now we have all kinds of applications where we don't need that. Then all the changes in data platforms. So NoSQL contributed to that. Now data lakes and everything. More and more platforms are being created. We were talking about that before we started, that, you know, it was really hard to develop a new platform when there were only mainframes, because I didn't have a mainframe in my basement. So I couldn't do a startup to make mainframe software. But now computing's everywhere. And of course, makes that really easy as well. The lack of governance, I work a lot in the data governance world as well. That lack of governance, and a lot of people push back on this governance word. They'll say it slows things down, it'll make, projects won't go as fast, we're agile. And yet most of the new legislation, I have another presentation where I talk about the legislation and regulations that impact our data designs and data architectures. Almost all of them these days require you to have a data governance program and a data governance officer, much like a privacy officer. So that's happening. Also, when I grew up learning about relational databases, duplication of data was, we should never have that. And yet now with modern architectures and distribution and having globally distributed data, we have a lot more application than we would have had 20 years ago. Integration seems to be the challenge always. And then data movement and data gravity, where data gravity is this trend to not do the way we used to do it, but to bring compute to the data, not move the data into compute. And that will show up in these architectures. And then the life cycles, and then the one I fight all the time, which has made the news a lot recently, is data literacy. So it's really hard to do proper analytics if you don't understand all the technical debt and issues with the current data. And then also, what does that data mean and how should it be used? Why is there 5 years of that data missing? And why are all your customers 300 years old when you use analytics? And then the big thing that leads to complexity is just people. Jerry Weinberg says every technical problem is a people problem, and I believe him on that. And then, like I said, the advent of more focus on AI and data, meaning using AI in analytics, using AI to help manage data quality, using AI to tune data platforms. And then also this whole concept of, is our data ready for AI? And then my other thing, data privacy and security and compliance are getting more and more important. I usually have in my presentation, everyone knows what ROI is, but the new definition of ROI is risk of incarceration. So I tell people, you need to tell your boss that you're keeping his butt out of jail by having good governance. So what does Karen mean by a data framework? Well, one of my frustrations when I started working on this is, of course, people call things a data framework, but other people disagree. And I was in a session at an analyst session a few months ago where just mentioning one of these frameworks I'm going to talk about in a discussion about frameworks got someone beat up, because two people felt it wasn't, not literally beat up, figuratively beat up, because they felt it wasn't a true data framework and we shouldn't be talking about it. So the common things I see in most of the things that I look at as data frameworks is they definitely have patterns of architecture or patterns of design. They all have some form of governance, but that's also contentious. they generally have really specific goals. And we're going to talk about, sort of as we go through them, what the goal was at the time. They're almost all based on modern architectures, although I think, the client server data framework is also a data framework. It just, we don't talk about it that much more. I'd also say modern data frameworks tend to have been created and are used because of the greater focus these days on analytics. So the other thing I find is that data frameworks are both logical and physical. And we get into a lot of these because, if I say something like our data lake integrates with our transactional databases, that's sort of a logical conceptual statement. If I say my Microsoft Fabric is going to mirror data from SQL Server, that's a physical way, and they're both true. They also all come with processes and policies. They generally lean heavy on standards as a way of managing complexity. I'd say the number one thing data frameworks do is they have this specific focus on integration because of this data gravity problem, because of data coming from many more sources than it ever did. And then finally, I'd say I consider something a data framework for this presentation if not specific to a vendor. Even though I'm going to talk about some vendor specific stuff, what I mean is data lake, data mesh doesn't imply a certain infrastructure vendor. So one of the things I do now on every presentation to cheat is I always go ask Copilot. Now I told you what Karen thinks data frameworks are. I went and asked Copilot, what does Copilot think? A data framework is a structured system or approach used to organize, manage, or utilize data efficiently, ensuring it can be accessed and analyzed effectively for decision making. Sounds really good. I'm not going to debate it. So some trends I've seen in data frameworks is they have been getting, so most of the things I consider a data framework have been invented or widely accepted, I'd say, in the last 10 years, some of them much more recent than that. And of course, like everything we humans invent, we always invent things and put things in place because we assume every person is good and there are no bad actors in the world. And therefore, now we're focusing on security, privacy, and compliance on these things. It's also a focus on data separately from any transactional applications that use it or any other applications that use the data. These frameworks, and I think the reason they're called data frameworks is because they focus on data as something that deserves to be something we manage outside of all the applications that use it or create it. Some of these really require demand for better data trust, and we'll talk about those things. And then I would say people tend to use the word data architectures and data frameworks the same way, unless when data architecture, they really mean something highly physical. I don't know how you guys are using it. So yeah. Okay. So I can't tell if someone's asking a question or someone just needs to go on mute. Sounds like someone had to go on mute. So these are the frameworks I have been reading up about and talking about, but I put a sort of on there because there's still a lot of contention about whether these are actually data frameworks. So there's data fabrics, data lake, data mesh, and I threw in the Zachman framework. I don't think it's a data framework. John Zachman doesn't think it is, but I keep hearing people talk about that. Then I also in Data Vault, which I don't consider really a framework. It's a modeling standard or process or approach, not necessarily a data framework, but people do talk about it that way. Then traditional data warehouse, definitely, I believe, is a data framework. We just don't call it that as much anymore because we're using it to mean modern things. And then, of course, big data. Big data was something new and big and data-ish. And it was a change from transactional to data warehouse. Now, the reason those last three are in italics is I'm not going to talk about them today. I'm not going to talk about Data Vault because I don't think it's a data framework. I'm not going to talk about data warehouse because there's plenty of presentations about that. And I'm not going to talk about big data because I think we're not using the term anymore and we don't refer to it as something different than the current data frameworks we're using. So let's start with data mesh. So I have a bias here about how I feel about it, and I'm not going to try to hide it. But these are the basics of it. The number one thing about data mesh is the core of it is producing data products. And that is data that exists, package it up as a product, you share it as a product. Um, Sometimes it's monetized data products, sometimes it's just whatever someone thinks about. Like you could have a data product for customer, and that would be, 25 years ago, we just called that an enterprise or something like that. The other key thing for it is decentralized, and they like to use the term democratized because there's no central management of the data, and the business owns the data. And this has always been a struggle over the years of, yes, business own the data, they steward the data, but sometimes business people don't have the same data literacy, they don't have the technical knowledge to do this. And it means that they end up sometimes making poor decisions about designing data or sourcing data or even using the data. And that's also something I'd love to talk about. It's perceived as a self-serve data infrastructure, definitely depends on cross-functional teams. They say it's a data quality focus, but what they really mean, it's a data quality focus as that group of people think about the quality of that data. This is optimized for data to meet the needs of the local group that owns it. And they also have requirements to make it usable across the company. But we've always had this trade-off, this conflict between overly designing data to solve one problem at the expense of other use of it. This comes from this original book was only a couple years old that lays out these parts of data mesh. And one of the things you're going to see here, I have some books where I tried to track down where these things came from. All of them came from Riley. And I don't know if that's because all my search is just optimized for Riley. If so, kudos to them. But the goal of data mesh is producing products. It's that, ownership. Decentralize the ownership and governance of data. It's a new culture, and there's no centralized governance. And that, for me, as a data governance person, like, I don't think we need an all-encompassing giant dictators of data governance. But one of the things I've always struggled with throughout my whole career working about data quality is that, if you're building an application and you're deciding what granularity of the data, what your rules are for data quality, you're often missing the needs of people down who are going to be using the data. And that's one of the theories behind enterprise data governance is data governance teams, while they have specialty data stewards or curators who work on certain pieces of the data, you have a management team that thinks about how the data should be managed so that it meets the needs across all the business lines. So also when I went to find reference architectures for a lot of these things, of course, I found mostly vendor ones, and I try to avoid those just because. So my go-to is to go to government things, since even though it's government things, they tend to not be so focused on a specific product or service. So I found this one from the DoD in the US that talked about data domains and the sources. And, I look at this particular example of a data mesh, and I'm seeing almost every data architecture diagram I've ever seen, except the words data product and data contract. Now, I didn't talk about data contracts because that would take me an hour to do, but I'm really intrigued by them. Data contracts are really when you have two parties sharing data, whether they're internal or external, you not only write a contract, not as a document, but as an integration policy that gets implemented into the integration layer. So an example would be if you have a data contract to get customer data from the customer data product team, you would negotiate how often you're getting it, what the granularity is, what the data quality rules are, how fast it would get to you, how out of date, how nulls are handled. You would negotiate all that. And then you would have tools that would examine the data being sent by the customer product team to you. And if it was in violation, you'd raise an automated flag. You'd either stop the integration, you'd send an alert, you might fine them if they're an external party. You might stop paying them. I don't know. The big difference here is I've always worked on teams where we wrote these requirements documents, but what's different about data contracts is they're automated. So it's both a documentation and something you build into your systems. I'm really keeping my eye on those.
Hey,
So,
Karen,
okay, yeah,
excuse me, you've got a question.
okay.
Is it with data mesh, does it lead to siloed and disconnected data?
So it's supposed to solve that problem, but in my mind, that's what I think is going to happen. But all of these frameworks have been built to do away with data silos, but that is one of my fears, is that by democratizing, decentralizing the management of enterprise data, it could lead to this more silo thing. The difference is these aren't application silos. These are actual data product silos, I think, by definition. So I'm also going to be trying to keep track of how teams, how do organizations manage this. So great question.
Okay, thank
Any
you.
other, yeah, any other questions of data mesh? Anybody? Okay.
Oh, we got somebody that's typing something in the chat right now,
Okay.
but no question has materialized yet.
That's a cat on a keyboard, I bet.
You know, it could be. Oh, yeah. No, I'm sorry.
No,
That was
it's okay.
that was the same question.
Okay. So, so data mesh, just sort of wrapping it up. A lot of people think this isn't a data framework, but more of a management framework. I think it's still a bit both. What's different for me is data mesh doesn't talk anything about the underlying technical architecture the way these other frameworks tend to do. And if you look at the previous one and this one, while it is mentioning things like security controls, APIs, storage, it's not really, it's very high level on the sort of what does this mean implementation wise, like we see just compute there on the left. And we see more of these management and governance things. I think that it's a good trend that we start thinking about data as a product and data consumers and data sellers, even if you're not getting money for them. That's a good way of thinking about data mesh. So the two things about data mesh, data products and democratization. So on to data lake. So another thing that's a cheat is I went to Wikipedia to see what Wikipedia did. And it has this very long definition that I'm not going to read to you. But I will say the underlying core thing for data lakes is that it tries to store data with no predefined schema, much like we learned in the NoSQL world, because the storage format is a non-SQL, non-relational format in general. It's usually a single store of data, including raw copies of the system data. Now, when this says single store, I think it's a logical single store because underlying, we don't really care whether it's, kept on this storage device or this type of thing, but it's logically to the end user, it's data virtualization, that the data is all in one place. Then it has both the raw data and sometimes transformed data. It can include structured data, semi-structured data, unstructured data, and binary data. Boy, that's a lot of data. And you can build a data lake on-prem or in the cloud. And this was coined by a guy named James Dixon, who was with Pentaho. I went to look to see if he'd written a book. I couldn't find any book he had written. Most of these people that come up with new things do it via a book. But he also was trying to fight the concept of siloed data marts when he came up with this. So data lakes have been kind of contentious over the years because some people misunderstood and they think you just shove a copy of your data all onto storage and let end users just fight to understand where it is, what it is, where the duplication is. And that's not really the intention of a data lake. So typically a data lake is based on open source formats. So Parquet, comma delimited files, just open source things. It, like NoSQL, is schema on read, not on write. That means that we don't predefine all the rules for the structure of the data. We just leave it out there in its form. I would say these days all data architectures are scalable, but data lakes specifically are scalable because you just throw more storage and more compute at it. And like I said, structured data, unstructured data, semi-structured data, it is not treated as transactional. It's not an application. It's basically data virtualization. It's really difficult to govern because of this. And also because like a lot of teams really misunderstood it and they literally just put a copy of their data in the data lake and said, if you build it, they will come. And people were left on their own to go find data and everything. It's not quite that sloppy these days, but that was the intent. My sad thing for this is the data quality was up to many people, like many people were responsible for determining, do I put this data in the data lake, even though I know most of the customers are 300 years old in it, even though I know there's 5 years missing because we couldn't find the file. You just threw everything into the data lake. So that's one of the critiques of it. But I did find an early book about it. And this is the Enterprise Big Data Lake. So that tells you kind of how old it is because it uses the term big data. And this is seen as probably the first book. Now, I have been spending time with Bill Inman of the data warehouse world, and I'm here to tell you he is not a fan of data lakes because it's the complete opposite of a data warehouse in his mind. But he's written a book. He's written a couple of books about data lakes on how to not mess them up. But I would say those books are really about building a data warehouse and calling it a data lake, in my opinion. So that's fine. He's the father, the godfather, the grandfather of data warehouse. So this is, and to quote him, very few can turn the data lake into an information gold mine. Most wind up with garbage dumps. So he's not a fan of them. And I'm not, if you talk to him about it, he will get very angry at data lakes. So I really couldn't find any good reference architectures that weren't proprietary that were about data lakes. So I did my fallback and I went to use the Microsoft one. This is on their page. That's just an introduction to data lakes. I don't think this really defines all of data lakes, but it does kind of talk in the general area of there's data, all kinds of data and formats coming. There's on-prem and cloud. There's big data processing, analytics, and reporting. There's a lot of things to data lake. But the thing I want to point out here is unlike data mesh, and unlike when we talk about the next, about data fabrics, data lake is really about how we persist data, like where it comes from. It's not about how we get the data there, what processes govern it. So I think data lake is kind of a logical physical framework, but not the way data mesh is or data fabric. This is why it's so hard to talk about these things. So I then pulled Microsoft's implementation of data lake. They've branded OneLake, and it's a little bit more than a data lake. It is a data lake plus all these other pieces that they talk about. And One Lake is also the core of their data fabric, which we'll talk about next. But the main thing that they're trying to get across here is that we store the data separately from how we're going to use it. And it has a lot of different data in it. And it is to make it look like to an end user that all the data in the company is in this one place. So what came after data lakes, though, because people did have a hard time governing it, they did have a hard time managing it, they did have oodles of duplicate data and data, like it was just a mess. It really was kind of Bill Inman's garbage dump. So then this concept of data lakehouse came up, and it kind of combines the best part of data warehouse and data lakes. What's different about it is, unlike a traditional data warehouse where it all went into a relational database or a quasi-relational database, data lakehouse includes both those free-for-all raw data plus structural data. And if you're building a data lakehouse, you can build it so it pulls parts of data warehousing, transactional support, whereas data lakehouse has no data lake has no transactional. There can be schema on write, there can be schema on read. There's a little bit more to data lake because if you design it with a schema, meaning a structure, and you have integrity and rules and constraints on it, it's easier to manage data integrity and quality. And you typically have a data catalog. Now, data lakes should have a catalog. They never do, because the people contributing the data never created a catalog. And one of the projects I worked with NASA with one time was to help them build data catalogs, because when they released all this open data, there was no catalog for the citizen scientist to go in and find out, what are these columns? What are the things between the commas? What does -1 mean in a sensor? And so everyone who works on open data now is much more understanding that you need either a data catalog or metadata or documentation, that horrible word, about all the data in a data lake. Any questions about data lakes or data lake houses? I want a data lake house. Okay. So now we have data fabric architectures, and Microsoft has their product, Microsoft Fabric. I'm not talking about that yet. So data fabric is also a concept of data being highly available and accessible to applications and end users. It allows a unified view of decentralized data, but not the way data mesh did. That data mesh data is decentralized, meaning physically and logically, and by process and by management. This is also a definition of data virtualization, of we don't care where it's stored, we don't care what format it's stored in, but to us, it looks like all the data is in one place, regardless of its format. Data fabrics has become really key to analytics. That's all I'm hearing about now. And I'd say AI initiatives, but I'd say that's a codependency. We're going to see AI initiatives in using, managing, and building data fabrics. And we're also going to have data fabrics contributing to data to AI agents and things. It also, like data mesh, moves some of the data management professionals into business units. And that was something I kind of skipped over in data mesh. I did say that the business units manage data mesh, they manage the products. But that doesn't mean there's no data professionals, no DBAs, no data architects involved in data mesh. It just means now that these business units, in order to be successful, need to retain and have these data experts inside their organization. Whereas in the past, in data warehousing, we had IT and we had business, they were separate. IT took care of a lot of times designing the data warehouse, building it, managing it, keeping it running. And data fabrics, I think, are still have that, but data mesh is against that they really don't want anything centralized. Oh, and I forgot to mention about data in the data mesh thing. the originator of Data Mesh comes from ThoughtWorks. And ThoughtWorks is the company, probably the most leading company in Agile. They have the founders of Agile, some very famous Agile celebrities work there or have worked there. And that to me kind of goes hand in hand with sort of the Agile manifesto or philosophy is there are no specialists. The business should call all the shots. You don't need DBAs or data architects or data modelers because everyone should be a generalist and understand how to do everything at a professional level. And that's something I disagree with. But that also says to me why someone would from ThoughtWorks would build something called Data Mesh and build in all these rules about no centralized governance, no centralized expertise, that it would be just down to a departmental team. So that's why I suspect that was developed that way.
I got a question.
Okay.
Getting back to the data mesh thing and
Yeah.
maybe even this data fabric for that matter, it just seems to me that there aren't any rules.
So how do I want to say this? That's the feeling. So, gosh, you can tell how much I think about this. So that to me is what I also felt with many agile implementations. So I've worked on a lot of agile projects. Um, there were rules, but in traditional agile, like fundamental agile, like Scott Ambler agile, the team makes all the decisions along with a single business user. And not everyone implements it that way. There are rules, but the team itself building something decides on the rules. So, in my mind, as someone who's into data governance, data quality, data management, that says there are a bazillion rules, which to me says there are no rules. And I think maybe that's where you're coming from. Is that kind of what you mean?
Well, I'm kind of coming from the I don't see data recovery in any of this. How do you know that you don't have duplicates?
But in all of these, you get to have duplicates. I pointed that out on a slide. In theory, you manage the duplication. That's the theory behind it. So the analogy I use is, I was raised on relational databases where you never duplicated data, except we did, but we did it in a managed way. Like calculated columns is duplicate data, right? It's just we let the database engine manage that duplication.
Mhm.
If we have highly distributed data for HR or DR or physical reasons, because we've got to put data in Singapore so they're not waiting 5 minutes for every time their query goes, that's a managed duplication of data. It's managed by computers or by engines or by Hadoop or something like that, or Cosmos DB. So there is duplication of data. But I suspect in the data mesh world, that duplication will not be managed very well, especially with things like master data, all of those things. Is that I don't know how you're going to let I call them departments, but they're not necessarily departments, every product group make all these decisions, implement how they want, set their own standards, and not have some issues with data quality challenges. So that's where I am on that.
Okay, thank you.
So, yeah. So allegedly, this is the first book written about data fabrics, and that was only in 2021. So the data mesh was in 2022. And I haven't read this one yet, but now it's on my to be read list. I don't know if anyone else has read any other books about mesh or lakehouse or fabric yet. I'd love to know if you have. So I swiped this from Gartner because I couldn't find any data fabric reference architectures, not even in governmental sources, open source sources. What I found were a lot of what some of us call NASCAR slides, which means a bunch of vendor logos all sitting on a slide saying, this is what you can use for storage, this is what you can use for lakes. And I don't find those that helpful in a discussion like this. But Gartner says it's an integrated layer of connected data. And to me, this is the big difference between data fabric and data mesh. And to a degree, data lakes, which I considered more like a story concept, not a usable concept. So this concept of you can have files in multiple formats, you can have data marts and data warehouses, you do ETL or ELT as you want, you have data lakes, you have things in the cloud, you can have things on-prem, you can have documents and PDFs and movies and all this stuff. And the data fabric is another way of looking at data virtualization. However, I think of it as a platform, especially Microsoft's implementation here. And yes, I was lazy and fell back on Microsoft Fabric because that's what I know the most about. So the Microsoft Fabric thing, as do most Fabric platforms, they consist of databases, and those can be relational or non-relational, data warehouses, storage, data lake, self-serve BI, and data factory, which is really integration, is what that means there. And they all have this kind of processes that go along with the platform of supporting real-time intelligence, of you have to have data engineering here. And I like the definition of data engineering. I didn't put it in here, but in Joe Reese's book on data engineering, and it supports data science. So these are kind of the things at a really high level that most Fabric implementations have. Now, I'll point out that I am talking about a service here, Microsoft Fabric. And of course, vendors can put anything they want into their services and products. But I'd say right now, Microsoft Fabric is pretty close to the traditional definition of data fabrics. That's why I put it in. So, also pulling from a Microsoft slide on fabrics, you can see this just provides a little bit more detail with their product logos of you can mirror Azure SQL DB into Fabric, the Fabric platform, and there are more coming soon. They have Data Factory, that's their integration level. They have data science support. There's a data warehouse inside Microsoft Data Fabric that is based on the Synapse platform. You have Power BI, all these other workloads. And then the other thing that's different is that all of these shortcuts. So shortcuts are, gosh, they don't use this word, but kind of a link or a pointer to data that isn't in necessarily persisted inside the Fabric platform. It can be, but it doesn't have to be. And shortcuts are ways of, they're almost like link tables in a database, of being able to bring data in or use data even into your OneLake without making a copy of it, without bringing data to the compute. And you have all these languages across the middle that you can work with: Spark, T-SQL, Kusto, and analysis services and those things. So the key to data fabric is you try not to duplicate the data and you try not to move it, because that has a performance cost. And then every time you duplicate data or have data that's not up to speed, not current, you end up making analytical mistakes. This is where I pulled that slide from. So, oh, no, this is an additional resource. I found this page on Fabric terminology, even though it's Microsoft's terminology on it. I found it really helpful when I was studying this. And then there's the Zachman framework. So I said Zachman framework is not a data framework. And by the way, the reason this is fuzzy is John does not put a copy of the actual framework on his website because people keep stealing it and republishing it. So he publishes the fuzzy version of it. He calls this an enterprise architecture, and it doesn't mean compute. It doesn't mean IT. It doesn't mean platforms. It's basically a framework of how we think about managing the enterprise that has different perspectives, going from the top, very conceptual, all the way down to the bottom, which is very physical, and then answers the 6 questions of who, what, when, where, why. And then he says there's a model or a way of thinking about each of those cells. So the what of an architect's perspective has this, entity thing going on. So what means data, how means process, where means location, who means responsibility, when means time, and why means can we afford to do this? He wouldn't say that, but why is really cost, benefit, and risk. So I don't know if anyone's familiar with the Zachman framework, but I keep hearing that it's a data architecture, and John for sure would not agree with that. So some of the challenges to get any of these to work, I mentioned data literacy, and this one really bothers me. In the past, we referred to data literacy mostly with end users so that we could teach them what our company means by customer, what our company means by department or region. But I think the bigger issue is the more we share data, the more we make data as a product, the more our lack of literacy, not in just how data works at all, but in what does it mean in this particular data source, is really going to be a big problem for us. And like I said, it's been in the news recently a lot. And then the next one, data ethics, also a big challenge, especially, I believe, in the decentralized models of frameworks, is data ethics that, there's kind of an overlap between security, privacy, and compliance and data ethics. And by data ethics, like, why did we collect the data? Did we get consent to use it for this other reason? Are we managing it at the quality level that we should in order to not harm people or animals or the planet? That to me is going to be a big challenge going on as well as we throw more data, more complexity into these things. Oh, and the big data ethics thing in analytics is, are we combining data in a way, even if it's been masked or anonymized, are we combining it in a way that we could figure out who these people were? And then the big thing with Fabric and Mesh as products is there's a big focus on how do we do integrations, but not the traditional way, not how do we move data, but how do we link all this data together to make that data virtualizations happen. The other problem that I've dealt with my whole life, you have too, the tools are having a hard time keeping up with all this new stuff. And I mean, I always had a tool that I did data modeling and database design that pretty much only supported relational databases. And then those vendors kind of threw in other, like document DBs and graph DBs, but they never really supported those things well because their bread and butter was in supporting relational databases. But now what we're finding is there's probably going to be fewer and fewer specialized tool sets as we have multi-platform, multi-location, multi-format, and that are sort of coding tools, things that used to be just developers do, are going to be having plugins and extensions so that everyone working with data has some way of doing it. And that might also include things like Power BI or Tableau or Qlik are going to have more features so that they aren't, I think we'll see less specialization in tools and more generalization. I think that the highly specialized tool vendors might not last for a long time if they stay highly specialized, highly targeted. And then the other thing that's going to drive us crazy is if governance used to be a enterprise-wide thing and now it becomes a departmental thing, or we have this mixture of it, or if DBAs were always in IT, but now they work in accounting, like how are we going to deal with changes of data processes that way? The other thing I'd say is we have these opportunities with these new architectures and frameworks that the push now with AI being such a huge word and many companies saying they need to do it to keep up a competitive advantage is that I think we're going to relearn our lessons that we had before with data warehouse. So if you had the pleasure of going from transactional databases to data warehouses, what we found was that as we tried to bring data together from multiple sources, and it was different teams than our transactional teams and our application teams, we found out there's a lot of technical debt in our data, in our transactional data. It's just that we dealt with that either with the application transforming the data itself and dealing with missing data and everything, Now you take that data with all that technical debt and data quality issues, missing data and duplicate data, and you throw it into a lake or a mesh or a fabric, people are going to find out our data is not the quality that they think it is. And so when we went to data warehouse, we learned that lesson and we fixed all the data quality problems in the ETL process. But now that ETL process, which is highly specific to transactional to data warehouse, isn't going to exist if we bring in all this source raw data into our fabric or lake houses, and we're going to learn this all over again. And AI is going to make that even worse because we're learning that same thing again. As been many news stories, and if you've ever played with Copilot or Gemini or any of those things, is that first the models might not be trained well. They might be biased because they weren't trained with the right data, but they also won't know how to deal with all these data quality problems because they don't have access to right now to the information about how they should treat these things for this specific data set. I think therefore, there's going to be increased money and demand for data related projects, efforts, tools, and skills. I think there's going to be a lot more hybrid cloud projects now that it's getting easier and easier to keep data on-prem, keep some in the cloud and in multiple clouds. I think there's going to be many more projects that aren't just for one of those. And then the advent of no-code, low-code technologies, especially for working with data, drag and drop analytics, all this magic that Power BI does. I think that's also going to lead to more opportunities. But one of the things, I think I mentioned it earlier, is that every design decision, that includes choosing a framework and how we implement it, must come down to cost, benefit, and risk. There's no one right answer. There's no, you can't just look at benefits. You can't just look at costs. You need to look at the net outcome of how much you're paying, what benefit you're getting at, and how much risk you're taking. So I've just got some slides in here. I'm not going to read them all, but these are my thoughts on how we can use certain data management concepts that are going to become important to all of these architectures and frameworks. So we need to think about how we're going to use AI on our own projects, whether we're a business person or a data architect or a DBA or a developer. And I'm looking forward to playing with AI on how it can and can't help me doing these things. Data capacity planning is going to be much different. Like we used to do data capacity planning for a server that held these databases. And now capacity planning, especially if you're using cloud things, you're buying service levels or capacity units that don't mean just this much of a machine and this much storage and this kind of CPU. And also how we do cost savings changes in the cloud and on-prem, and how we license software on-prem is likely going to change significantly over the next few years. I always throw this in, and we need test data, even when we're building all these things, fabrics and data lakes and everything. But we got to stop using production data for test data. We need to have synthetic data that's more realistic, and because that will be faster, cheaper, and better than using production data. And I'd love to debate that with anybody. The other thing that's going to change with us with all these new architectures is how we observe and monitor data, and how we measure the quality and measure all these things. We're going to have to revisit the data prep that we do because these are all activities in all of the frameworks. And we haven't done a lot of these things if we're still on the traditional transactional systems plus data warehouse. Now there's going to be many more places the data is going to be used and logic will go. And then data quality, because that's my thing, is that who's going to do the data quality and what is the acceptable data quality given that we have such a variety of data. The other thing that I didn't talk about here, but that's really important to me is, it's just now that SQL Server and Oracle have data classification tools built into their tool sets. That means, is this PII data? Is it sensitive data? Is it name or contact data? Is it salaries, that kind of stuff. So I'm looking forward to AI helping me do this, where it's going to look at the actual data, not just the names of the columns and tables. It's going to see patterns in data. It's going to see anti-patterns to see if maybe our data's been corrupted and helping us identify more data anomalies. I'm happy about all these challenges. Even though it sounded like I was negative about things, I'm happy about it because we are innovating for the benefit of data, for the love of data. And so this is what I want to happen. And also I say, just like in space exploration, the universe is made of data. So that's all I had for this year. I wonder if we have any questions or if anyone just wants to talk about their observations. Do I have to start calling on people?
Well, I have a question.
Yeah.
It's not, this is just more of a curiosity question. This, have you ever thought about, volunteering to, go up out in space with, like what a lot of these celebrities are doing?
So the short visits, I'd be happy to do now, and I'd be super excited if I got to do that. The long-term things, I think when I was younger, I'd love to do it, or if I was much older, I'd want to do it. I just feel like I got things to do here right now. That's my thing. What's your answer to that?
My answer, well, I, I don't know. I'm like 72. I think I'm too old.
Not too old, unless you're saying you wouldn't feel like doing it. Because one of the interesting things is that many space agencies are looking at really diversifying, the types of people. Like we went from fighter pilots, super fit fighter pilots, to the shuttle thing, where it's mostly scientists and doctors and life sciences people who aren't always the most fit and don't have a fighter pilot culture. And I think in the future, we're just going to see that people, like, there'll just be jobs that are done in space, either on the moon or a space station or maybe Mars. Not in my lifetime, I don't think, but there's all that. So I see some questions in the chat, though. So one of them is about the hackathon from Jason. So it can be challenging to participate in a hackathon, but what's great about the Space Apps Challenge is not all the challenges require building any code at all. Like sometimes you look at open data, you do your analysis on it any way you want to, like load it in a spreadsheet and sort things, or put it into a Microsoft Fabric and do analytics. And you're supposed to come up with observations or insights about the data, or prepare an optimal data visualization to show this type of data or these anomalies. So that's what I love about this hackathon is even though they use the term hackathon, it's really a bunch of data challenges. And like I said, if I was a judge in this, I'd totally be doing the art ones and have no artistic skills. I'd totally get open data and make something pleasantly beautiful with it, maybe a song.
This is Jason. Thank you for that clarification. The hackathon items that you showed on the screen that I briefly saw showed like a web application was needed to create something.
Yeah,
so
and that's a common one. Yeah, that's like a lot of them do have, like some of them are make a game, and most people choose to make it on a web-based game platform or something like that. But yeah, you should go to that spaceappschallenge.org website and go to the 2024 event and go see what the challenges are. Like I just pulled a little snippet from it. I should have pulled one of the art ones because that's my favorite one. Yeah, I think it's all of the questions there. So is anyone actually working on a project or working at your half-aunt stepsister-in-law's dog groomers beauticians company where they're implementing data fabrics, data mesh, or data vault or Zachman frameworks or any of those things? I'm not working on any of those either, so I'll be the first to admit to that.
Well, we started out with the data vault at one time.
Yeah.
And we had it set up in Aurora,
Yeah,
but it was quickly, well, it just basically put it up on the shelf. We got more of a situation now where the is take the data and I guess if I had to define it, it would be a data lake.
yeah. And like the only reason I put data vault on here is because people call it a frame. It's, as far as I'm concerned, a data modeling approach. That's all it is. I shouldn't, that sounds like I'm disparaging it. I'm not. I'm just saying it's not a framework and it's not an architecture. It's just a way of designing how you persist data. So, okay. Well, I'm really glad people came to hear me rant about all these things. And I had a link on the slide. I realized it's an old one where I put the slides. So I'll send that to you where I put the slides, Ross, and then you can share it however you want. Does that make sense? You're on mute.
Where did you put that? Was it did you put it in the
So
chat?
no, I'm saying I will send you the correct link.
Oh,
I don't
okay,
have
got
else
you.
on this. I used to use SlideShare, now I don't. And so I use Speaker Deck or something like that. So I'll send you the link to Speaker Deck where you can find the slides.
Okay, great. Thanks, Karen.
Okay. Thank you so much for having me.
Yeah,
Thank you, Karen. I don't have much to
Thank
add, but I took a lot of notes and check out some of those books. I appreciate your presentation.
Thank you so much. Everyone have a great evening.
Thank you.
Okay, well, I'll be putting this recording out on our website in a couple of days. Thanks everybody for attending, and we'll see you next month. Thank you. Thanks,
Bye.
Karen. Bye.
Mhm. Bye.